Orthodontic tooth separation activates the hypothalamic area in the human brain. Yoshiko Ariji, Hisataka Kondo, Ken Miyazawa, Masako Tabuchi, Syuji Koyama, Yoshitaka Kise, Akifumi Togari, Shigemi Gotoh, and Eiichiro Ariji. International Journal of Oral Science Volume 10, Article Number 8, 2018. DOI 10.1038/S4136801720001 year. Abstract. Objectives. An animal experiment clarified that insertion of an orthodontic apparatus activated the trigeminal neurons of the medulla oblongata. Orthodontic tooth movement is known to be associated with the sympathetic nervous system and controlled by the nucleus of the hypothalamus. However, the transmission of both has not been demonstrated in humans. The purpose of this study were to examine the activated cerebral areas using brain functional magnetic resonance imaging, MRI, when orthodontic tooth separators were inserted, and to confirm the possibility of the transmission route from the medulla oblongata to the hypothalamus. Methods. Two types of alternative orthodontic tooth separators, brass contact gauge and floss, were inserted into the right upper premolars of 10 healthy volunteers. Brain functional T2 weighted images and anatomical T1 weighted images were taken. Results. The blood oxygenation level dependent, BOLD, signals following insertion of a brass contact gauge and floss significantly increased in the somatosensory association cortex and hypothalamic area. Conclusion. Our findings suggest the possibility of a transmission route from the medulla oblongata to the hypothalamus. Introduction. Tooth separation is frequently used in orthodontic tooth movement, and it usually causes uncomfortable sensations, including pain around the tooth. In animal experiments, the mechanical pressure caused by insertion of orthodontic elastics elevates neuronal activity in trigeminal spinal subnucleus caudalis, VC, neurons of the medulla oblongata. 1,2 Activation of VC neurons may be transmitted to the cerebral somatosensory cortex, resulting in recognition of pain around the tooth. The activation of the somatosensory cortex by other painful stimuli has been confirmed in human beings also. 3 Regarding tooth movement force, however, it has been confirmed solely by a recent in vivo study with rats. 4 Meanwhile, pain as an afferent stimulus is considered to play a role in tooth movement through activation of the central nervous system. 2, 3, 4, 5 Tooth movements are performed by both bone resorption and formation through the sympathetic nervous system, which may be regulated by the hypothalamus. 6, 7 Indeed, the intervention of the central nervous system is verified indirectly by the fact that administration of non-steroidal anti-inflammatory drugs, NSAIDs, for pain relief impairs the tooth movement process in orthodontic treatment. 5 Although the activation of the medulla oblongata is verified in tooth separation. 1, 2, the route of transmission signals to the hypothalamus from the medulla oblongata has not been verified in human beings. Although differences in afferent stimuli may cause different degrees of activation in the somatosensory cortex and hypothalamus, even activations themselves in these areas have not been confirmed in orthodontic tooth separation for human beings due to the lack of appropriate procedures. Recently, functional magnetic resonance imaging, fMRI, was introduced as an effective tool for non-invasively identifying the anatomical brain areas that are activated by afferent signals. 8, 9 Taken together, if fMRI would indicate the activation in the hypothalamus area, the possibility of a transmission pathway to the hypothalamus from the medulla oblongata could be verified. The purpose of this study was to identify the activated cerebral areas using brain fMRI with a special emphasis on the hypothalamic area together with the somatosensory cortex. In this regard, 2 types of orthodontic tooth separators were inserted between the upper premolars of healthy volunteers.